Number 2, football. The height in feet of a football t seconds after it is thrown is modeled by the equation h of t equals negative 16t squared plus 96t plus 5. Find the relevant domain and range of the ball, rounded to the nearest tenth. Now that word relevant means kind of like real world. So if you think about this graph, since we have negative 16t squared, that's going to be upside down parabola. But instead of saying this goes on forever, both directions, that would not be the relevant domain. That would just be its overall domain. We're going to say that we know this football is going to be thrown, and at some point in time, it's going to start, and it'll be, if I'd have to curve that over a little bit, it'll start here, and it'll end when it hits the ground. It'll be thrown at some height, plus 5, it looks like, so it'll actually be up a few units. It'll go up in the air and hit the ground. We're looking at the domain from the time it was released. If this is time in seconds, what we'll do is we'll just kind of cut off this graph there and cut it off here. So we're only looking at values in the first quadrant. That's basically what we'll do here. So let's go to the graph and we'll see it. So I'll go to add graph, and my equation was negative 16, and instead of t I have to do x squared, and then we have, let's go back over here, plus 96, plus 96 x plus 5. Now it's hard to see that here, and I can see it's hitting the ground at 1, 2, 3, 4, 5, 6. So what I'm going to do is I'm going to go to Window Zoom, and Settings. And I'm just going to change the axis. I'm not looking for the negative values, but I want to be able to see the axis, so I'll just do -1. We know it hits the ground around 6 seconds, so I'll just go past it to 7 seconds. And I'll hit OK. The X scale tells you what you want to count by. I'll just put I want it to count by ones. I'll hit OK. Now, I didn't do anything with the Y's. The reason why is you can go to Menu, Window Zoom, and if you do Zoom Fit, it'll go ahead down here. It'll change the graph where you can see the whole of the graph. It changes the y-axis without affecting the x-axis. So I want to know the relevant domain and range. That means I need to figure out that we know that we go as left as far as here, which is at 0. And it should be 0, 5, because that's what this plus 5 is. Let's just check it real quick. We want to know analyze graph, a few different things. First, if you go to analyze, the 0 will be where it hits the x-axis. I can come over here and get exactly where it hits the x-axis. It's at 0.605. This is just this e to the negative 11, which means the decimal needs to be moved over left 11 times. This is basically 0. Over here, that's going to be a y-intercept at 0.5. If you're not sure, hit Control-T, and you'll see it's 0. It's at 5. You can see just like I was saying. So that's what that point is there. It's 0.5. Let me take off the table here. And we're going to need to know the highest point. So I'm going to go Menu, Analyze Graph, and I'm going to look for the maximum here. And it looks like it's 149 feet. So now we come back over here. And now that we know the picture, let me actually take a picture and move it over. I now have this picture, and we can look at it. We can say, okay, for the relevant domain, we're not going to look at when the time is negative, so all this goes away. So for the relevant domain, you would start when the time is 0, and we could be equal to a 0 time. That's when we start, and we go all the way till the ball hits the ground, which is 6.05 seconds. Again, we can hit that time equally. It's like that. Now it says round it to the nearest tenth. Now this is going to round up. So to round to the nearest tenth, this would actually then, let me do squiggly equal sign because we're rounding. I want to say from 0 to 6.1. And now I go on to the range. Now the range is talking about the lowest value to the highest. Well, again, the ball hits the ground. So that's the lowest of 0. And now the highest value is here at 149. That's the highest the ball ever travels. And I would just leave that one in that regard. So that would be my answer. I've circled them up. That would be my relevant domain and the relevant range.